Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 asks, what is the Ka for a strong acid like HCl? Okay, so let's show why hydrochloric acid is a strong acid. So when HCl is in water, it completely dissociates into its ions, H plus and Cl minus. So I'll just write that down. Strong acids completely dissociate to their ions in water. So if we are given the concentration of our strong acid, this is equal to the concentration of H plus ions in solution. So then in order to solve for the Ka, just realized that the question asked for Ka and not pH. But I'll just first I'll just show that the pH can be found with strong acids just by doing the negative log of your H plus. But if we show the dissociation of HCl in water, then we get something similar where we have H3O plus and the chlorine ion. So when we need to solve for the Ka can be expressed by multiplying the H3O plus ion concentration by the concentration of the chlorine ion divided by the concentration of the strong acid. So by knowing the concentrations of H3O plus and the Cl, it's going to be equal to the concentration of that strong acid. Okay, so let's see what the junior tutor said. Strong acids completely dissociate in water. In the case of HCl, the equation is HCl plus H2O makes H3O plus chlorine. Hence, the equilibrium constant Ka is given by H3O plus concentration times the Cl minus concentration divided by concentration of HCl. Since the acid dissociates completely in water, concentration products will be very large and the concentration reactant will be very small. If the numerator is a very large number and the numerator is very small, I think they mean if the numerator is very large and the denominator is very small, it will result in a very large value. Hence, Ka will be very large at about 10 to the 7. Yep, so this solution is correct. Okay, so I just kind of fixed that typo. Okay, so question number 2. Is K3PO4 an acid or a base? Okay, so this is a type of salt. And there are 3 types of salts that you could potentially have. So there is an acidic salt, which is formed from a strong acid and the salt of a weak base. You could have a basic salt, which is formed when you combine a strong base with a weak acid. And lastly, you can have a neutral salt, which is what is formed when you react a strong acid with a strong base. Okay, so K3PO4 is formed from H3PO4, which is a weak acid, and potassium hydroxide, which is a strong base. Okay, so I can show out how this reaction would take place. We have our weak acid plus our strong base reacts to form K3PO4 plus water. Okay, so if we were to balance this equation, we'd need a 3 in front of the potassium hydroxide. And now we have 6 hydrogens and 7 oxygens. So let's see if we put 2 in front of H2O. And now everything should be balanced. 4 hydrogens, 6 oxygens, 3 potassium, and 1 phosphorus. Okay, so therefore K3PO4 is a base, or a basic salt. Okay, so let's see what the junior tutor said. K3PO4 is a salt solution. This salt is formed through neutralization of strong base and a weak acid. Salts that are from strong bases and weak acids do hydrolyze, which gives it a pH greater than 7. The anion in the salt is derived from a weak acid and will accept a proton from the water in the reaction. This will have the water act as an acid that will, in this case, leave a hydroxide ion, OH-. The cation will be from a strong base, and it will dissociate into an ion and not affect the H+. So K3PO4 is then a basic salt. Okay, so this solution is correct. Okay, so question 3. When an acid reacts with a base, what compounds are formed? So this is also known as a neutralization reaction. And in a neutralization reaction, an acid reacts with a base, and the compounds that are formed is a salt and water. Okay, so I'll show the most general or the easiest neutralization reaction. So let's say we had hydrochloric acid plus sodium hydroxide. This will form sodium chloride, which is a salt, plus water, H2O. And the junior tutor said that the reaction between an acid and a base is called neutralization. This reaction forms a salt and water. Yep, so this solution is correct. Okay, so question number 4. What is the structure of a polypeptide? Okay, so even just looking at the name polypeptide, you'll see that it has a prefix of poly, which means kind of like there's many of it involved. And then peptide means that there are many peptides. So it can be described as a chain of amino acids. Okay, so I'll show a general reaction of 2 amino acids. So every amino acid contains an amine group with their carbon and a carboxylic acid functionality. And what makes every amino acid unique is the R group that is on our carbon. So I'll denote this as R. So this reacts with a different amino acid, or it could be the same, but again, it will also contain an amine group. It will contain a different R group, so I'll name it R prime. And it still contains a carboxylic acid. So what happens is a dehydration synthesis that involves the removal of water so that these 2 molecules can come together to form a larger molecule. And this continues, and you can have a long chain of amino acids. So then our product is the first amino acid, and now it is attached to the amine group of our second amino acid. And this can continue on to form a long chain of amino acids. And then from there, you can form what they call secondary, tertiary, and quaternary structures. Quaternary. That can be formed. Okay, so the junior tutor said that a polypeptide is composed of chains of amino acids which are bonded together by peptide bonds. Okay, so they showed where the peptide bonds are located. I'll label it on mine as well. So this is an example of the peptide bond. The two ends of a polypeptide are composed of the amino N-terminal and the carboxyl C-terminal groups. Figure below shows an example of a polypeptide. Okay, so this solution is correct. Okay, so now on to question number 5. When an ionic bond forms, which parts of the atoms are directly involved? So, to answer this, valence electrons of the atoms are directly involved. So I'll show an example of how an ionic bond can occur. So let's say we had sodium chloride, and we start off with our two atoms. So we have sodium, and it has an atomic number equal to 11. And since this is the number of protons when it is a neutral atom, it has the same number of electrons. So when I draw out my neutral sodium atom, I have my 2 electrons in the inner shell, and then I'm going to draw my 8 electrons in the next shell. So now this is 10, and sodium has an extra 1 electron in the valence shell. And then this comes together with a chlorine atom, and chlorine has an atomic number of 17, I believe. Look at a periodic table before to double check. Yep, so 17. So I'm going to draw the same 2 in the innermost shell, 8 in the next shell, so that's 10. So now I'm going to draw 7 of its valence electrons in the outermost shell. So now you can see that in order for sodium to have a full octet in its outer shell, it wants to donate one of its electrons. And in the case of chlorine, it just needs 1 more electron to fill its octet. So in the case of an ionic bond, a sodium atom donates one of its electrons to the chlorine takes the electron, and that's how ionic bonds are formed. So I'm not going to draw the whole thing again. I'll just show that there is now a bond with the sodium and the chloride. But I'll show that the chlorine has the lone pairs around it. And this is the ionic bond. And you can see that the inner electrons didn't really partake in the reaction, they all kind of just stayed the same, and only the valence electrons were directly involved in forming the bond. So the junior tutor said that when ionic bonds form, the outermost electrons are the part of the atoms that are directly involved. Ionic bonding is defined as the complete transfer of valence electrons between atoms. This is the type of bonding that generates two oppositely charged ions. Since valence electrons are the outermost electrons in an atom, it is the part that is directly involved in ionic bonding. Yep, so this solution is correct. Okay, so question 6 says to give the common names for the following compounds. So first we have a benzene ring that contains a single amine group. So the most common name for this compound is called aniline. It can go by other names as well, but this is the main one, so I'm just going to put like a star. But it can also go by like phenyl, amine, or even aminobenzene, or benzenamine, which is like least common. Now let's look at our second compound. We have another benzene ring, but this time there is a single aldehyde that is attached to it as well. And the most common name for this compound is benzaldehyde. Okay, I believe another less common name for this compound could also be benzoic aldehyde. But again, benzaldehyde is most commonly used. And then for our last compound, we have another benzene ring. This time there are two groups on it. We have an alcohol group and a chlorine as well. So notice that the two are in the meta position. So that means there's like a one. Yeah, so this is what the meta position looks like. If they were beside each other, it would be the ortho position. And if they were on the opposite ends, then it would be the para position. But this is the meta position. So to show that it's meta, you put an M in front of the name. And its most common name is M-chlorophenol. So the chloro corresponds to the chlorine, and the ol corresponds to the alcohol. So this is the most common name for this compound, but another name that it could go by is 3-chlorophenol. So the reason that it's 3 is because the alcohol group is carbon 1, and then if we number it towards the chlorine, then the chlorine is on carbon 3. Okay, so let's see what the junior tutor said. Phenol, benzaldehyde, and benzoic acid, marked in the red photo, are some of the common names that are retained in the IUPAC system, IUPAC nomenclature, according to the indexing prefix preferences of the chemical abstracts. And the IUPAC system, other terms including toluene, styrene, naphthalene, or phenanthrene can also be used in the same way. While the use of other common names is generally appropriate, their use is discouraged in the nomenclature of compounds. So here they have a lot of other examples like benzonitrile, toluene, acetophenone, and the left compound has a common name of aniline. The center compound in the picture has a common name of benzaldehyde, and in the rightmost compound there are two substituents connected to benzene. Instead of using numbers to denote substituents on a benzene ring, it is appropriate to use ortho, meta, or para instead of positional markers when there are two substituents on the benzene ring. They can be described as ortho, which are next to each other in the benzene ring. Let me show what that would look like down here. So this is ortho chlorophenol. This one was meta. And then I'll show para as well, just to complete the three types. And this would be considered para. Okay, so then the junior tutor said 1, 2 next to each other, 1, 3 separated by 1 carbon, and then 1, 4 across from each other in a benzene ring. And the compound OH and chlorine are separated by 1 carbon in a benzene ring. So the common name for benzene with OH attached to it is phenol, and the name of this compound is then M-chlorophenol. Okay, so this solution is correct. Okay, so question number 7. Consider the following solvent pairs when mixed. Which pair will form 2 layers? If they form 2 layers, which solvent will be on top? Okay, so to answer this question, let's recall the phrase that like dissolves like. So when we have a polar substance plus another polar substance, this term is referred to as miscible, so that means they dissolve each other. Similarly, if you have nonpolar plus another nonpolar substance, then they dissolve each other as well, and they don't form 2 layers. But if we had a polar substance mixed with a nonpolar substance, then that means the two are immiscible, and they will form 2 layers. Okay, so let's start off with hexanes and water. So hexanes are nonpolar, so they only contain carbon and hydrogen, and those are all nonpolar bonds, and they all have like carbon and hydrogen have a similar electronegativity, so there are no dipole moments involved. So this is a nonpolar substance. But water, on the other hand, is polar. So therefore, they will form two layers. And if we were to look at the density of the two, you'll see that hexane has a smaller density, so it will be on top. Okay, so now let's look at B. Water plus methylene chloride. So methylene chloride is also known as DCM. And it's actually a polar substance. So these will dissolve. I'll just say that they'll mix. But typically DCM is heavier. So if it is left just sitting there for a long time, then it might just sink to the bottom. So it just kind of like depends on the situation. But typically, because methylene chloride is polar, they would mix. So it's one of those tricky kind of compounds. So C, hexanes, and methylene chloride will form two layers. And again, the hexane will be on top. D, methanol plus hexanes. So methanol is polar. So they will also form two layers. I believe hexane will still be on top. Next we have ethanol and water. So these two are both polar. So they will mix together and no layers will be formed. And then lastly, we have acetone and toluene. These will also mix together. Okay, so the junior tutor said that in determining whether the two solvents we will mix, we will apply the concept like dissolves like. Two solvents have the same properties, they will mix, otherwise they will form two layers. In determining which of the two solvents will be on top, we need to compare their densities. Solvent with the lower density will float and be on top, while the one with the higher density will be at the bottom. So A, hexanes are nonpolar, water is polar, so they will form two layers, and hexane will be on top. And they also included the density as well. B, they said will form two layers. I'm just going to add a note that this explanation is correct. Okay, so I just added just a bit about methylene chloride. So they said water will be on top and the methylene chloride will be at the bottom. So you can see that its density is like 1.33. So you can see it has a much higher density than water. That's why layers might form. C, they will mix. So again, they said that methylene chloride is nonpolar, but it is still considered a polar molecule. So I'll write down the structure of methylene chloride. This is the structure. So it contains 2 chlorine atoms, which are both electronegative. So it will form a dipole moment within the molecule. Okay, so D will form 2 layers. Methanol is polar, hexanes are nonpolar. E, it will mix. F, it will mix. Acetone can be mixed with almost any solvent, and toluene can be mixed with almost any solvent except water. Yeah, so it's a pretty tricky question sometimes when you work with like methylene chloride, but the explanation is correct. So I'll still say that the solution is correct. So question 8, what is the oxidation number of chlorine in Cl2? So this is a diatomic molecule, and the chlorine just has an oxidation number of 0. If it were bonded to almost any other atom, then typically chlorine has an oxidation number of -1, but in the case of this diatomic molecule, it has an oxidation number of 0. So the junior tutor solution is correct as well. Okay, so question number 9. Which of the following processes is endothermic? Okay, so let me describe endothermic and exothermic reactions. When we have an endothermic reaction, this is when heat is absorbed from the surroundings to the system. So I'll also add that heat is a reactant, you could say as well, if it makes it easier. And when we have an exothermic reaction, this is pretty much the opposite. So heat is released from the system to the surroundings. So for exothermic reactions, heat can also be considered a product. Okay, so those are our 2 scenarios. Let's look at all the options they give us. Freezing of water. Okay, so when we freeze water, then that means heat is released. So when we have liquid water and it's like warm, then the heat is in the system. But once we start to decrease the temperature, then the heat is kind of released from the water and ice is formed. So this makes it an exothermic reaction. So I'll just say this is exothermic. B, the combustion of propane. Okay, so when we have a combustion reaction, this releases energy and heat. So this is also an exothermic reaction. C, we have a hot coffee cup as the system cools on a countertop. So coffee cooling. So this is similar to when water is freezing. The heat is being released from the system to the surroundings. So this is exothermic as well. D, the chemical reaction in a hot pack, often used to treat sore muscles. So hot pack. So what takes place is that the hot pack releases heat. So the hot pack is like, yeah, it's pretty much a hot pack that you put on your muscles to kind of relieve the pain. And since it's hot, it gives off this heat onto your muscle pain, and that's how it is used to treat the sore muscles. So since this releases heat, again, we have another exothermic reaction. So this leaves us with E. So process of elimination, this is probably the endothermic one, but let's see what it says anyways. The evaporation of rubbing alcohol. So when we have an evaporation reaction, this is also the conversion of a liquid to a gas. So if we think about the conversion of liquid water to water vapor, when we boil the water, then this converts liquid water to a gas. So we can say the same thing about just the evaporation of rubbing alcohol. When we have the process of the phase transformation of a liquid to a gas, this requires energy, which can be in the form of heat. So therefore, this is our endothermic reaction. And our answer is then option E. Okay, so let's see what the junior tutor said. The energy is released during a certain process. The process is called an exothermic process. On the other hand, if energy is absorbed, the process is endothermic. Option A, freezing of water, involves a process in which water molecules are changed from disordered liquid to a more ordered solid phase. In this case, energy is released, hence it is an exothermic process. The combustion of propane. In general, combustion reactions are reactions where the energy is being released. Therefore, this is an exothermic process. Coffee cup cools on the countertop. So in this process, the heat from the coffee is being released to the surroundings. Thus, it is an exothermic process. Chemical reaction in a hot pack, often used to treat sore muscles. Considering the hot pack as the system, it releases energy to the body. This is considered an exothermic process. And then lastly, E, evaporation of rubbing alcohol. Evaporation is a process where a more ordered liquid particles are changed to a less ordered phase, which is gas. Energy is needed for this process, thus it is an endothermic process. Yep, so this solution is correct. Okay, so now question 10. The hydrolysis of 2-bromo-2-methylpropane yields 2-methylpropan-2-ol. Give the SN1 mechanism. Okay, so first let's write the structure of 2-bromo-2-methylpropane. So if we try to write down the structure of this compound, let's first identify the parent group. So when we have prop, this means that our parent chain is 3 carbons long. And the fact that it ends in ane tells us that there are only single bonds involved. If it ended in ene or ine, then it would have double or triple bonds, respectively. Okay, so we know our parent chain, and now we can see that our substituents is a bromine group. So 2 on carbon 2. And we also have a methyl group on carbon 2 as well. Okay, so now that we have deconstructed our word, let's write what this would look like. Propane is 3 carbons long. So we can number them 1, 2, and 3. And then on carbon 2, there is a bromine group. And also on carbon 2, there is a methyl group. And then carbons 1 and 3 just have hydrogens. Okay, so let me erase the numbers. Okay, so this is 2-bromo-2-methylpropane. So we need to write out the SN1 mechanism. So when we have an SN1 mechanism, it's typically like a 2-step reaction, but I'll go over all the different steps. So first we have a leaving group that leaves our compound. In the case of this 2-bromo-2-methylpropane, the most likely leaving group would be the bromine. So bromine is a common leaving group. So this will leave our compound and it will form a carbocation. So carbocation can also be pronounced like carbocation, so it just depends. But carbocation, that means that we have a carbon that is now positively charged. So because it is positively charged, it will attract our nucleophile. So in this case, let's say that our nucleophile is a molecule of water. So one of the lone pairs on the water molecule will come in and try to neutralize that carbon. And then we are left with the following intermediate. that now has a water molecule attached, but this oxygen is now positively charged. So in order to relieve that positive charge, another water molecule can come in and deprotonate. So it removes one of the H atoms, and this will neutralize that positive charge. And this forms an alcohol group. And we are left with the following product. Okay, so if we wanted to name this compound as well, let's number it again, just so that we can compare it with the question. So in order to name this, we need to find out what our parent carbon chain is. So this will be the longest carbon chain containing all the most important things. So in this case, it is this 3 carbons as our chain. It can also be the top one as well, but just to make it easier, I'll circle the 3 that are in a row. So on carbon 2, there's a methyl. So to name this, it would be 2-methyl. And then when we have an OH as our substituent, this is going to be put at the end of the word. So I just need to name the parent, so propan. And then on carbon 2 is our alcohol, so 2-all. And then let's look at the question. So this yields a 2-methyl propan 2-all. So we know that we did the mechanism correctly. Let's see what the junior tutor said. Step 1, this step involves bond breaking. Thus, it is a slow process and is the rate determining step. Okay, so see, they form the carbocation with the bromine group acting as the leaving group. Step 2, this is a fast reaction because the partially negative charge on oxygen and water is attracted to the positively charged ion. The nucleophile water attacks the carbocation in this step. So they show it attacking the positively charged bond. And now we have this intermediate that contains the oxygen. So I think they just put the oxygen on top of the carbon, but it should look like the intermediate that I have. Let's see what they have down here. Step 3, deprotonation of the organic product occurs while reacting to 1 molecule of water. So they have water coming in to deprotonate. So I don't know if they meant to put the oxygen in the middle like that, but there should be a carbon kind of like in between. So this explanation is correct. And all the steps are correct as well. However, there should be an additional carbon in the red spot. I don't really know how to. OH. I'm not sure if it was like a typo, but just so that the future students reading the mechanism and take note that this oxygen shouldn't like be in the middle. It should be attached to another carbon that should be in the center of the product. Yeah, so they just had it like coming in and replacing the carbon in there, but it should just be attached to the carbon in the center. Hopefully my explanation kind of made sense. I'll just say this is incorrect for now because the structure can be kind of like misleading. Even though all of the explanations are correct. Okay, so those are all the questions for today's session, and if you enjoyed today's Q&A and you'd like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you'd like to submit a question of your own, then check out the links in the description. And also, if you enjoyed today's video, go ahead and give it a thumbs up and comment, and you can share it with your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.